Back in Algebra 1, you first learn how to take points like these and graph them, and you formed a line. And then you were asked to do things like, well, we'll find the equation of the line that goes through those 2 points. And you learned about this idea called slope and also the y-intercept. And then you learn how to actually calculate the slope and the y-intercept and come up with an equation like this, y equals 2x minus 3, that would actually go through these 2 points. Well, in this video, what we're going to do instead is we're going to take some points, and instead of a line, we're going to find the equation of the exponential curve that goes through those points. So, with no further ado, let's get it on! In order to find the exponential function equation here that will work, that will go through these 2 points, we're going to need to go ahead and find the multiplier and the base. The first step is to realize, hey, we have these 2 points, which means we have an x and a y, and we have a second x and a y, and we're going to use these to create 2 equations. In our first equation, we're going to go ahead and plug in the y and the x, so I'm going to go ahead and I'm going to say 0.1875 is our y equals a times b to the power of -2. And then for our second equation, we're going to say 192 would equal a times b to the 3rd power. So we basically have 2 equations here where we have 2 unknowns, a and b. Our next step is going to be simple. We're going to take one of them and we're going to solve for a. So let's go ahead and I'm going to take the top one. If I solve this for a, I'm going to divide both sides by b to the -2 power. So I'm going to wind up with 0.1875 over b to the -2 equals a. And I realize this -2 throws a lot of people off, and all we have to do to fix that is, I'm just going to write on the other side over here, we can move to the top of the fraction and change the negative to a positive. So it's going to end up being 0.1875 b squared. So now we know what a is equal to in terms of b, and we can go ahead and plug it into our second equation. So rather than having an a, we're actually going to plug in the 0.1875 b squared. So we're going to wind up with 192 equals 0.1875 b squared. That's what a is now equivalent to, times b to the 3rd. Well, we all know what b squared times b to the 3rd is. That's b to the 5th. So we're going to wind up now with 192 equals 0.1875 b to the 5th. Grab your calculator and you're going to take 192 and divide by 0.1875. And when you do that, you're going to wind up with 1,024, and that's going to equal b to the 5th. So really what you're doing right now is you're thinking to yourself, what number to the 5th power is 1,024? In case you don't know what that is, which is possible there, you can go ahead and you can take both sides and raise them to the power of 1/5, or if 1/5 is equivalent to 0.2. So I'm going to go ahead and do that, and the reason why you can do this is the power rule with exponents is you're going to multiply. So 5 times 1/5 is 1, so we're going to get this over here is just b, and 1,024 to the 1/5 power, or if you prefer, to the 0.2 power, ends up being 4. So now we know what b is. So essentially at this point right now, we have the equation y equals a times 4 to the power of x. And now the last thing we need to do is find out what a is. So let's go ahead and do that. Pick either point up here. It doesn't really matter which point you pick. I'm going to pick the second one. It's probably a little easier to deal with. So y is 192. A is what we're trying to solve for, times 4. And then we're going to plug in the 3 right here where x is. 4 to the 3rd power is 64. So 192 is going to equal 64a. And if you divide both sides by 64, you're going to get 3 equals a, which means when we're all said and done, here is our final equation. Y equals 3 times 4 to the power of x. That is going to be our glorious answer right there. And just to show you graphically how this works is I went ahead and went to Desmos. I graphed the equation y equals 3 times 4 to the power of x, plotted the 2 points. You can see the 2 points right over here, and you can see obviously that the exponential function that goes through those 2 points. So that's further proof that the equation we came up with actually works. As always, if you like what you see, please like, comment, or subscribe. Thank you, and now back to part 2. Another type of problem that you might see is where not only are you given 2 points, but you're given a horizontal asymptote that's different from the standard graph of y equals 0. So in this case here, the asymptote is going to be y equals 8. And all that does is it moves the graph up 8. That's going to be our k value. Let's go ahead and write our 2 equations. So the first one that we have our x and our y right here. So that means we're going to say 12.5 equals a times b squared, and then we're going to go ahead and say plus 8. With our second equation, same thing over here. We're going to say 129.5 equals a times b to the 5th power plus 8. The first thing I would do is just go ahead and subtract 8 on both sides of the equation here. So if I subtract 8 here and I subtract 8 over here, I'm going to wind up with 4.5 equals a times b squared. Let's go ahead and do this over here too as well. If we subtract 8, we're going to wind up with 121.5 equals a times b to the 5th. So that was just to make things a little simpler here. Let's go ahead and pick one equation and solve for a. I'm going to take the top one. So if I solve that for a, I'm going to go ahead and I'm going to divide both sides by b squared. So 4.5 divided by b squared is going to wind up on the left side of the equation, and that's going to equal a. If you want, you can also write that as 4.5 times b to the negative 2 power. And I actually prefer that because in a moment here, we're going to plug in this value into the second equation. So we're going to go to the second equation here, and wherever we see an a, we're going to replace it with this 4.5 times b to the negative 2. Kind of running out of room here. I'm going to go ahead and write it over here. So I'm going to say 121.5 equals 4.5 b to the power of negative 2 and then times b to the 5th. Well, according to our exponent rules, if we have the same bases and we're multiplying, we just add these together. So 5 minus 2 is 3. So now we're at 121.5 equals 4.5 b to the 3rd. From there, we're going to go ahead and divide by 4.5 on both sides. When you do that, you're going to wind up with 27 equals b to the 3rd. So really you're asking yourself, what number to the 3rd power is 27? And I realize many of you know that is 3, so that is actually our answer here. B is going to end up being 3. However, if you didn't know that, what you would do is you'd raise it to a power of 1/3. So you do 27 to the power of 1/3. And the reason why that works again is 3 raised to the power of 1/3. You just multiply together, that's 1. So that would give us our b to the 1st power. Alrighty, so we're getting there. So I'm going to take this top equation right over here, and I'm going to write it as 12.5 equals, I still don't know a, I know b is now 3, so I'm going to write that in, squared, and then I have plus 8. So what is 3 squared? Well, we know that's 9, so we can say 12.5 equals 9a plus 8. Go ahead and subtract 8 on both sides. We get 4.5 equals 9a. And then if we divide both sides by 9, we're going to wind up with a over here. And 4.5 divided by 9 is 0.5. So that's going to be our a value. So when we're all done, our equation is going to be 0.5 times 3 to the x power plus 8. It's always nice to have graphical proof this works, so I've gone ahead and graphed the exponential curve, the 2 points, and also the asymptote this time. And you can clearly see that the curve goes through the 2 points again and also narrowly misses hitting the asymptote down here. Thanks for joining me.